I'm going to ask you a question. When adding and subtracting, what's the first thing we need? Yep, and not only just a common denominator, don't we truly want a least common denominator?
Yeah.
Now, once again, we don't really truly know what's in common unless it's factored. I like to keep my things the same, like my steps the same. So I highly recommend factoring out your denominators, because what if there's an x plus 1 in common you're not seeing right now? So we have x over, what is this factor to be? X plus 2, x minus 2, minus 2 over x plus 1. Now we are able to see they don't have anything in common, correct? So let's go in sections. Now x minus 2 is connected. The only way to get an x minus 2 over here is to already have an x minus 2 or to multiply by x minus 2. So our least common denominator, we need an x minus 2. We need an x plus 2. And then we need an x plus 1. So guys, make all your denominators look like this. So what does this one need? The front thing here. The front term, what does it need to get the denominator to look like that? X plus 1. If you have two terms, you need parentheses. What does this one need to look like that? X minus 2, x plus 2. Now this is where a lot of people are doing something that I highly do not recommend you doing yet. A lot of you are then just extending your signs. You're going, shoot, wrong, don't do that. Because it's confusing. The next step when adding and subtracting is to multiply out the numerator, correct? So I have x squared plus x, don't I? All over x plus 1, x minus 2, x plus 2. You do not simplify. Then we have over here negative 2 times all this stuff. Wouldn't it be smart to multiply all that stuff first? Which is x squared minus 4, isn't it? It was that. Now, negative 2 times x squared is negative 2x squared. A lot of people mess up on negatives. Negative 2 times negative 4. Plus 8. We've already distributed our negative through all over x plus 1, x minus 2, x plus 2. Now, guys, look. Our denominator is the same. Why did we get a common denominator? So we can now combine the numerator. Your next step, you do not simplify right here. Your next step is to combine the numerator. Negative 2x squared plus 1x squared. Negative 1x squared. Then we have plus x, don't we? Plus 8. And that's all over. Now we can write it over one fraction, x plus 1, x minus 2, x plus 2. You'd say, that's my answer. I just better check to see if my answer simplifies. So we do that by factoring the top, factoring the bottom, and dividing out exact factors. What do you recommend me factoring out on top? Then left is x squared minus x minus 8, all over, and then x plus 1, x minus 2, x plus 2. Now let's check. Does this quadratic factor, what multiplies to be negative 8 and adds up to be negative 1? 4 and 2, 1 times 8. Nothing. So we are done, because nothing factored to divide out. So those of you that got it wrong, do you see how you were just tackling it by the wrong way? Because you were confusing the ideas. Like I said, it is easy to. It's hard to remember. So just remember those steps with adding and subtracting. Okay, erase your whiteboard or just on your notebook. I need you to simplify both of these so we can make sure we have the different ways of simplifying in your head very clearly. Notice there's the same problem, but one's addition and one's multiplication. Simplify them both. This is a review for you to make sure before we move on that you're good with the old stuff. So in this one, we need a least common denominator. So I don't really know what's in common unless my denominators are factored. Rewrite the original. AP, pull out a 2, left is b plus 4, am I right? Plus 6 over 4. Now, least common denominator, 4 is the same thing as 2 times 2, isn't it? Okay, let's find the least common denominator. What do they have in common? A 2, so we're good with that 2 and that 2. And then what else, though? What's not underlined? We need a b plus 4, don't we? And what do we need here? Another 2. What's 2 times 2? 4. So we need our denominators to be 4 and b plus 4. Does everybody see how I found that? Now, let's fix that. So looking at this one, how am I going to make this 4b plus 4? Multiply by what? 2. So I'm going to multiply to the bottom and the top by 2. I need this to be 4b plus 4. Isn't it already 4? So I'm going to multiply by b plus 4. What's the next step? Multiply out your numerators. So that's 16b over 4b plus 4 plus 6b plus 24 over 4b plus 4. What's the next step? Combine the top, the numerator. So you would now combine our numerators. So we would get 22b plus 24. And that's all over 4 times b plus 4. Now we're to the step. So we're done. Now we got to simplify. How do we simplify? Factor the top, factor the bottom, divide out exact factors. You should pull out a 2 on the top. So then pull out a 2, divide by 2, divide by 2. Left is 11b plus 12. And on bottom we have a 4 times b plus 4. We know we can divide across the multiplication sign as long as it's not connected to an addition sign. So isn't that 1 over 2? So my final answer is 11b plus 12 on top, all over 2 times b plus 4. Raise your hand if you got it right. Nice. Very good. Those of you that are getting them wrong, are you seeing what's going on? Because this was a second common denominator one. We should be getting them more right. Okay. Awesome. As long as you're seeing what you're not getting right, that's why we're doing this, is to help you before we get to the test. Okay. Let's do this one. How do we, these ones are the easy ones. These ones are multiplication. Don't we just multiply straight across? So we have 8b times 6 on top, divided by 2b plus 8, all over 4. Now, shouldn't I just factor it out? Everybody? And divide out exact factors. Multiplication is our friend because it's the easy one. So now once again, okay, on top, technically, I have 8 times 6 times b, don't I? I'm just putting the pretty stuff in front. What should I pull out here? 2, so then left is b plus 4, and then we have times 4. So isn't it prettier to go, I'm going to put 4 in front and cross that out. Okay, sweet. Let's divide out things that can divide out. We have an 8 on top and a 4 on bottom. Wouldn't that be 2 over 1? Now, don't we have the 2's divide out? So what's left on top? 6b and then b plus 4. Yeah. Same thing, right? I just didn't put it together, right? The same thing, right? So that's 48 over 8, which is 6 over 1. Does everybody see? It's just different ways of thinking of it, both correct. Yeah. $48b. No, what you did, okay, 48b, and then on bottom you had a 8b plus 32. What did you factor out technically? This is what you actually did. You factored out an 8, didn't you? Then left was b plus 4. You divide across an addition, a multiplication. So that's what you really are doing by dividing all of them. Does that make sense? So that's 6 over 1, same thing, right? Very good questions, very good questions. That's what you're essentially doing when you divide all 3. Does that make sense? Okay, cool. All right, try another one. Once again, helping you to see where you're at before we take this test in the next few times. You shouldn't be getting every single one wrong, and if you are, that's a good indicator that I need to go to Miss Christensen and get some one-on-one time help. Let's go through it together. So how we simplify, which remember is the last step in our problems, is back to the top, back to the bottom, divide out exact factors. Right here, what should we pull out from the get-go? A p. Divide by p, divide by p, divide by p. So left is 2p squared minus p minus 3. Does this factor more? Yeah. So this actually factors to be p times 2p minus 3. Am I right? Yeah. And then p plus 1. Okay, now I didn't take the time to long factor this because I know that on your own you can do that, correct? Now on bottom, what should we have pulled out? Yep, 3p squared, divide by 3p squared, divide by 3p squared. What's left in my parentheses? 2p minus 3. Now we'll state our restrictions. That's really important that you state the restrictions before you divide anything out. P cannot equal what for that piece? 0. Does anyone need me to go into more detail of that? If so, I really can. But if we're all good with that, I don't need to. I can explain more. You need me to. Okay, and then, or what for this piece? 3/2. Now can we divide out exact factors? As long as it's a multiplication sign, not connected to an addition sign, right? So we have a p on top and a p squared on bottom. So wouldn't that just be a p on bottom? And then these divide out. So left on top was p plus 1. Left on bottom was 3p times, nope, that's it, just 3p. Okay, try another one. Dividing fractions easy as pie, flip the second, and multiply. So I flipped the second fraction. Now we're multiplying straight across. So with this one, I'll just extend my line, throw in my parentheses. These are being multiplied here. Now don't we just factor and divide out exact factors at this point?
Oh, my birthday gift finally.
It was sitting up there like the whole time. I just forgot. I'm sorry. Pull out a 2x squared out of this group. Left is x plus 1. What would I pull out of this group? It's 3x squared. And then left is... Now careful because don't confuse this. Like this is all multiplication. So wouldn't it be prettier to put this in front and this in front? So 6x to the 4th times x plus 1 times x minus 3. All right, let's factor out the bottom. What should I pull out here? An x, left is x minus 3. What does that factor to be? X plus 2 and then x minus 3. Okay, so now we would restrict. So x cannot be 0, 3, negative 2, and we don't need to list 3 out twice. And then we'll divide out exact factors. X to the 4th and x divides out to be x cubed, doesn't it? And then x minus 3's divide out, and that's it. So we have 6x cubed on top, and on bottom, x minus 3 times x plus 2. Awesome job. I saw a few of you get that right. Very good. We have quite, yeah. And there's an x plus 1 on top. Good catch. Before we said that was our final answer. So this is truly the final answer there. Very good. Okay, questions, guys? If you got it wrong, are you seeing that you're maybe just tackling it wrong again? Okay. Try this one. Ready, go. Then we'll get on to today's lesson. So, guys, watch. This one's easy, but, like, pay close attention because I don't want to confuse you. Okay, so common denominator. Now, we could factor this, couldn't we? But are we going to get a 1? Is there anything in common, in other words? No, so we would just be able to go ahead and say, okay, I'm going to multiply by 6x squared plus 5x minus 4 over 6x squared plus 5x minus 4. So we have x over 6x squared plus 5x minus 4 minus 12x squared minus 10x, am I right? Plus 20, and that's all over 6x squared plus 5x minus 4. Plus 8, it's now plus 20. Now we're gonna combine our numerator at this point. So combining our numerator, we'll have negative 12x squared, and then minus 9x plus 8, and that's all over 6x squared plus 5x minus 4. Now you would factor the top, factor the bottom, and divide out exact factors. Does that make sense? The bottom does factor. And then we would check the top, and then we could pull out a negative 1, and then we could look, and the top doesn't factor. So think about it. If the top doesn't factor, will it divide out with anything even though the bottom factors? No, so we could leave our answer like this. But once again, we would want to go through and factor it if possible. Anyone confused? We went through that one kind of fast. Okay, let's get to today's lesson, 4-4. So what we're doing today is we're solving rational equations. I need to point something out. Okay, guys, the difference in this problem is now we're dealing with an equation, an equal sign. We're solving for x in this one. Before, look at all the examples from the lesson. Did you see an equal sign here? We were not solving for x, we were simplifying. Not solving for x, simplifying. Same. Look, no equal sign. We're not solving for x, we're just simplifying. Do you understand the difference? So now we're going to be solving a rational equation. So here's the rule. You might want to write it down. When solving a rational equation, you need to get a common denominator. The nice thing is, once you have a least common denominator, you can literally just solve the numerator. You can just solve using the top. So you can, once you have a common denominator, you can ignore it and just solve the top. So look at this example. Isn't our denominator already the same? We're trying to find the x that's going to make this a true statement. So because the denominator is the same, we can literally ignore it and just solve using the top. So my statement is x minus 2 plus x minus 4 equals 2. Solve for x. So it's just a linear equation. X plus x is 2x. Negative 2 minus 4 is negative 6. Does everybody see how I'm just solving? That equals 2. How do we get x alone? Add 6. So we have 2x equals 8. Then divide by 2. So x equals 4. Now here's one thing we need to do. Everybody listen. That's my answer. I need to check to make sure my answer gets to stay. So this is what you're going to do. You're going to take 4, your answer, you're going to plug it into the very first original equation and see if it's a true statement. So let's do that. So we have 4 minus 2. Do you see why I put a 4 minus 2, everybody? Divided by 3 plus 4 minus 4, putting in my 4, over 3. Does that equal 2 over 3? This better be a true statement or else we have to throw out that answer. Let's see. What's 4 minus 2? So I'm going to do it right here. We have 2/3 minus, no, it's plus. What's 4 minus 4? 0/3. Does that equal 2/3? Yes, 2/3 equals 2/3. That's a true statement, so that is a solution that we get to keep. Now, if we were to check 4, let's pretend we checked 4, everybody. Let's say we plugged in 4, and our equation came out to be a not true statement. Well, it was a true statement. Let's pretend it didn't. Let's say it came out to be 6/5 equals 2/3. That's not true, correct? Then we would have to throw out the solution. We would cross it out, and that's called an extraneous solution. So it did work. It's not extraneous. But let's pretend we checked it and it didn't work. We would throw it out. It's an extraneous solution. So in this one, let's pretend it didn't work. What I would literally do is then cross it out and say, okay, there's no solution since that was our only solution and it was extraneous. So what happens is when we're manipulating these equations, when we're getting a least common denominator, we're changing up the problem. And even though when we solve, we get an answer, is it an answer of the original equation? Well, we don't know until we plug it back in. So basically, guys, check your answers. If it's right, keep it. If not, throw it out. Does that make sense, everybody? Okay, let's do another one. All of mine are coming off your worksheet. Here we go. Number 1, we're solving for x. We need a least common denominator because then we can just solve the top. So 6 is my least common denominator. Let's make all of our denominators 6, everybody. How am I going to make 3 a 6? By 2 over 2, how am I going to make this a 6? 3 over 3, how am I going to make this a 6? 6 over 6. So everybody, let's rewrite what we have. We have 2x over 6 plus 3x over 6 equals 60 over 6. Now look at our denominator. Isn't it the same? Yep. We can ignore it now. Solve using the numerator. Because our denominator is the same, we can just solve the numerator. So my true statement is 2x plus 3x equals 60. This is just a linear equation. 5x equals 60, solve for x. X equals 12. You divided both sides by 5. Now let's check to make sure it's not extraneous, because didn't we have to change the problem up a little bit? We changed it up correctly, but we just need to make sure. The hardest part is honestly checking it, you guys. Because people will check it and call it extraneous when it's really not, or they'll not check and it is extraneous. So let's check it. Here we go. It's got to be plugged back into the original. Here we go. So we're going to have 12 over 3 plus 12 over 2. Does that truly equal 10? Let's see. 4 plus 6 equals 10. Does 10 equal 10? Does everybody see where I plugged it in? 12, 12. Isn't that the only place you can plug in our answer, guys? So it's a true statement, isn't it? Yeah, so we get to keep it. Questions on that? Hey, flag boy. Pay attention, please. Hey, number 2. Yeah, I'm so funny. Here we go. Okay, what's my least common denominator? 9x. Let's make all of our denominators 9x. Here we go. What am I going to multiply this one by? Okay, very good, flag boy. What about this one? Good. And how about this one? Thank you. Wait. Let's multiply straight across. So we have 9 over 9x minus what? X squared over 9x. That equals 0 over 9x. Now look, aren't your denominators the same? Hallelujah. Ignore them then. Let's solve using the top. Here we go. My true statement is 9 minus x squared equals 0. Now look, this one came out to be a quadratic. We can solve quadratics by factoring, quadratic formula, or just solving, depending on the problem. This one's just solve, right? Just get x alone, right? Okay, what should I do first? Okay, so we have negative x squared equals negative 9. Next step, divide by negative 1. So x squared equals 9. Next step, square root. So x is equal to plus and minus 3. Wasn't it a quadratic? Do we need 2 solutions? So let's circle those. We have 2 solutions. We've got to check both. So go off to the side and make yourself like a little bucket of checking. So let's check x equals 3. Plug in 3 back into the very original. So that would be 1 over 3 minus 3 over 9. Does that equal 0? 0 equals 0. Isn't that what we get? If you don't know, type it into your calculator. But this one is, look, 1/3 minus 1/3. Isn't that 0? 0 equals 0, so we get to keep x equals 3. That really is a solution. Let's check negative 3. Plug in negative 3. 1 divided by negative 3 minus negative 3 over 9. Does that equal 0? Guys, I want you all to type that in. Let's see if you get, the hardest part is typing it into your calculator, right? I'm not kidding you. Second hour even saw. They all had a hard time until you get good at it. Did you get 0? So 0 equals 0, so we get to keep negative 3. None of them were extraneous. Okay, let's do another one. Okay, here we go. Least common denominator. What? X plus 1 and 3x plus 1. There was nothing in common in the denominators, so the only way to fix it is to multiply by each other's denominator. So this we're going to multiply by 3x plus 1, aren't we? 3x plus 1. This one we're going to multiply by x plus 1. Now look at your denominators. They're the same, so we can ignore them. Yes. Because that would be 3x plus 3. Is that the same as 3x plus 1? No, so that's why if it's connected by an addition sign, the only way to fix it is to multiply by that whole thing. That's actually a lot of people want to do that. That's a really good question. Okay, let's continue. We can ignore the denominators. So let's go. Negative 4 times 3x. Negative 4 times positive 1. That equals 5 times x plus 5. Now look, we have a linear equation. In this one, we need to put our x's together. So let's use some algebra and put our x's together. Let's add 12x, add 12x. So then look, it's just a linear equation. Don't overthink it. Negative 4 equals 17x plus 5. Solve for x. Aren't we trying to get x alone? What should I do next? Subtract 5. Negative 9 equals 17x. Next step. So let's go off to the side. X is equal to negative 9 over 17. This is one of the harder ones to check. Let's make sure we have to check though. Let's go back. Watch. Your calculator does not know what's considered on bottom and what's considered on top. So if there's 2 things on bottom, you've got to use parentheses to indicate to your calculator what's on bottom. if there's two things on top, you've got to use parentheses around your top to make sure it knows what's on top. So watch. Plugging this in, I have -4 divided by, in my calculator, it doesn't know what's starting on bottom. I've got to put a parenthesis because then it knows where my bottom starts. Then aren't we plugging in -9 divided by 17? And then +1, type that in. Give me a decimal.
0.4.
Nope. -8.5. Now we're just seeing if the decimals are the same. We don't need to put it as a fraction or anything. We're just seeing if this is a true statement. Is that equal to, let's type this in. Once again, your calculator doesn't know what's starting on bottom, so you need a parentheses. Then 3 times parentheses -9/17, close it, +1, close your parentheses. Type it in. It's -8.5, this side. Check it, type it in. The hardest part's checking your answers. You've got to tell your calculator where the top starts and ends, basically, unless there's just one thing. Does that kind of make sense of what I'm saying? Your calculator might know where. Okay, did you get -8.5? Yep. On both, you should have got -8.5. If not, that's me needing to help you just type it in your calculator, right? Okay, sweet. So we gotta keep it. Okay, another one. Here we go, number 4. What's my least common denominator? 4x. So what does this one need? 4/4. This one needs x/x. So now I would multiply straight across. So then I have, now can I ignore my denominators, people? So we have 16 equals x squared, right? So x is equal to what? Yep, now let's check. Let's do our little checking. So plugging in 4, that would be 4/4. Does that equal 4/4? That one's a dead giveaway. Yes. Look, 4/4 equals 4/4. 1 equals 1. Yep, that's a true statement. Let's plug in -4. So that would be 4/-4. Does that equal -4/4? Is -1 equal to -1? So we get to keep both. Let's pretend one of them didn't work. We would then say, okay, x equals 4. Let's pretend -4 didn't work. It did, but let's pretend it didn't. Then we would just say x equals 4, and then showing your work, you would write, it's extraneous. I highly recommend it just so that you don't, when you see that word, you don't freak out on a test. Because people don't get used to that word. They say, what does extraneous mean again? Because I might say, which one is an extraneous solution? Does that make sense? Just so it doesn't throw you off. Okay. You all see. So the only solution would have been 4, if that would have been true. But they both work. So they both get a 6. Questions? Okay, let's go. Number 5. What's my least common denominator? 12. 4 times 3. Okay, let's make this 12 when we multiply by 3/3. When we multiply by 4/4, don't I need parentheses? Because there's 2 terms. Now look at your denominators. They're the same. So we can ignore them. Let's solve this. So don't we have 9x equals 20x plus 4. Solve for x. What should I do? I put plus 14, but I really meant plus 4. Yep. Minus 20x, not a bad idea. So -11 equals, -11x equals 4. Solve for x. Divide by -11. So x is equal to -4/11. The hardest part is some reason checking fractions, typing it into your calculator. So you would go like this. Calculator, parentheses, because your calculator doesn't know what's on top. 3 times -4 divided by 11. Close it so that it knows all of that's on top divided by 4. Does that equal? We've got to use parentheses on top because there's 2 things. It's not going to know what's on top. 5 times -4/11. Close it. Plus 1. Close it. Divided by 3. Practice typing it in.
Cool.
Tell me what this decimal is, even if it's just like 2 decimal places. -0.27. Type in this side. Did you use parentheses how I indicated? No, you didn't.
Nope.
Negative 0.27. Guys, if you're not getting that on both sides, you're not following the directions of the parentheses. Are you good? Number 6. Guys, don't let this one throw you off. Look, is there anything in common in these denominators? Don't say the 2x. It's connected to the minus 3. So isn't that all connected, everybody? Okay, so those two x's have nothing to do with each other. So my least common denominator is literally 2x minus 3 and 5 minus 2x. Okay, so this one needs a 5 minus 2x over 5 minus 2x. And then doesn't this one need a 2x minus 3? Now we could reorder this, couldn't we, in standard form and then get a common denominator. That would all be fine. In fact, I would recommend doing that for problems where we're not solving. But when we're solving, don't we just get rid of the denominator anyway? So it's not going to matter that much. That's why with solving, I don't worry about it too much. But other problems I would. Like when trying to find these common denominators of adding and subtracting, I would have reordered that. Does that make sense? And if you did reorder this, right now you would still get the same answer as we would. Okay, let's multiply this in. So we have 15 minus 6x equals 2x minus 3. Solve for x. What should I do? Add 6x. So I have 15 equals 8x minus 3. Add 3. 18 equals 8x. Divide by 8. So x is equal to, we're trying to solve for x. So we would divide by 8. X is equal to 9/4. Then we would check our answer. So let's go. We would go like this, parentheses on all that stuff so it knows what's on bottom. Two equals 2. So it's true. We have not run into any extraneous yet, but you might in the future. Nope. Okay. All right. What I want you to do right now is practice 7 through 9. Check them off with me. 13 through 21. Check them off with me. Actually, hey. So, everybody go to this one, number 11. So Braden makes a good point. It is probably smart for us if we see something not in standard form to reorder it, because then remember there might be something we missed, right? So I didn't on that one problem because I saw that it didn't matter in that problem, but there are problems it does matter. So shouldn't we just get in the habit of always reordering it? We got the right answer. It's fine because that one it didn't matter. So look at this one. So once again, let's reorder this in standard form. What are we trying to do? Get a least common denominator. Now in here, there's stuff already in common in some of these. So that's what we're going to figure out here. Factor out the bottoms. So shouldn't I rewrite this as negative x plus 3? So then factored is actually negative 1 times x minus 3, isn't it? And then we have equals 6. Oh, we better factor this. Don't we get x minus 3, x plus 3? Now if we wouldn't have factored out the bottoms, we wouldn't have seen that there's already a lot of stuff in common. So my least common denominator, let's start here, x plus 3, correct? Then we're going to need a negative 1, and we're going to need an x minus 3. Now let's look over here. X minus 3, x plus 3. Haven't we listed those out? So let's see, our least common denominator is negative 1 times x plus 3 times x minus 3. So what does this denominator need to look like this? A negative 1 and an x minus 3. A negative 1 and an x minus 3. Does everybody see? What does this one need? X plus 3. And then what does this one need? Negative 1 and negative 1. Okay, now look at your denominators. They're the same, so we can now ignore them. Solve using the top. Negative 1 times 2. Yep, so I actually am looking at negative 2 times x minus 3 plus 5 times x plus 3 equals negative 6. Okay, let's do this. Negative 2x plus 6 plus 5x plus 15 equals -6. Solve for x. Shouldn't I put these two together? You know what I see people do? They add 2x, but we're not moving across an equal sign. Aren't we just combining like terms? So we have 3x from those two, and then 6 plus 15 is plus 21. And that equals -6. We're solving for x. That's trying to get x alone here. So what should I do next? So 3x equals -27. So x is equal to -9, correct? Let's check it very quickly. We would have 2 over parentheses -9 plus 3 plus 5 divided by parentheses. We're plugging it into the original. So then we're going to have -9 minus 3. Does that equal 6 over? We're plugging it into the original, so I'm going to just put it in standard form. Now, careful, your calculator needs to have parentheses around -9 squared. And then, what was our original? Plus -9? Okay, -9 here. Like this. But you've got to have parentheses around the -9 squared as well. Anytime you're substituting it in, you probably should use parentheses. Oh, so maybe that. So type it in. Does this side equal this side? This whole side is -0.33. Did anyone else get that? Yes. We're plugging it. Oh crap! That is right. If I would have scrolled up, shouldn't I be doing right here 3 minus -9? Good catch. So let's retype in this decimal. Sorry, I couldn't see the original, so I forgot because I'm still in rush. Anyways, they do come out to be the same, but once again, the hardest part is being able to do that for the text. Because what if you type it in wrong on the text and call it extraneous when it's not? That would be sad. They are equal. If you need help typing it into your calculator, that's a whole nother just you and me, one-on-one. Let me see what you're doing and explain to you why that doesn't work. Okay, so -9 does work. So once again, this is what I want you to do for homework, okay? So you're going to do problems 1 through 11 on the front. Write this down. Do not cross out anything else. It's a short day, so we're going to finish up a little bit next. Just more examples next time. 1 through, it's not that we have to learn anything new with it, because we've learned everything we need to know. I just want to do some more advanced examples with you before I tell you to do those ones on your own. So 1 through 11 on the front, 13 through 21 on the front, so just ignore that. And then go to the back, and you're going to do 1 through 5 on the back. Don't cross any out. Once again, I just don't want to give you those more advanced ones until we've done some more examples together. At least go that far, because I'm only going to spend the next part of class. I'm going to spend about 20 minutes to make sure you're good with this.